Question number 7. Find the greatest prime number x which satisfies the following inequality. Now, if you look at the left-hand side of this inequality, I'm dealing with the modulus function. And if you recall, according to the modulus function, it depends on what we're dealing with. Inside this absolute value, it could come out as positive or negative depending on the nature of the value inside the absolute function. Having said that, I'm dealing with two scenarios or two cases here, and those scenarios actually depends on the value of x. Now, if the value of x is greater than 57, my denominator is gonna come out to be negative since the numerator is already positive, so that means the whole fraction becomes negative. So I have to negate it before removing the absolute value, and with a simple cross multiplication, I get negative x squared is less than negative 5x plus 285, which if I bring everything to one side, I'm going to end up with x squared minus 5x plus 285 is less than 0. And this inequality has no real solution simply because if you look at the coefficients, also known as a, b, and c respectively, which can help me to build my discriminant, which is nothing but b squared minus 4ac, it's gonna come out to be a negative value, and that means I have no real solution. So let's move on to the case number 2, where x is less than 57, and that means this fraction on the left hand side comes out positive if we just remove the absolute value sign. And with a simple cross multiplication, we're gonna get negative 5x plus 285 on the right hand side, bring everything to one side, and this is the inequality I'm dealing with now. Unlike the first case, I do have real solution. I'm gonna be using the quadratic formula to find my answer. So one would be negative b minus b squared minus 4ac divided by 2a, and the other one is gonna be b plus negative b plus b squared minus 4ac divided by 2a. So basically the x is gonna be bounded between these two values. Now, if I substitute a, b, and c, which are 1, 5, and negative 285 respectively, I'm gonna get half of negative 5 minus square root of 1165, and for the upper bound I get half of square root of 1165 minus 5. Now, since the question says what's the greatest prime number that I could get, let's put our focus on the upper bound. Now recall that I'm not allowed to use a calculator, so very quickly I need to figure out what's the value of square root of 1165. I'm just gonna put some numbers into test here. If I choose 33, so that would be 1089, and for 34 square I get 1156, which is slightly less than this number. So that means the square root of 1165 is 34 point something. So ignore the digits after the decimal point and let's stick to 34. 34 minus 5, and then you divide 29 by 2, which gives you 14.5 or 14 point something, because again, I'm not looking for a very exact value. I'm just trying to figure out a rough estimation here. And don't forget, I rounded already this number to 34. Now, I guess the answer is very easy here. If x is less than 14 point something, then the greatest prime number that exists for x has to be 13, and that's answer choice A.